audio right now, but we can still look like we're talking.
And you can hear us.
Okay, I think they can hear us now.
In fact, I didn't even say any words. I was just practicing. Welcome back to the final day of Live CTF at DEF CON 2025. I'm Josh,
I'm Mark.
as is tradition, and we are ready for the semi-final round of Live CTF.
It's been a long road, but
It has. I was just listening to some team talk. Shellfish has 5 wins. Maltese also then has 5 wins.
well, I guess the upshot is the winner of this match is going to go to the finals, and the loser is out.
Absolutely. So without further ado, let's get ready to get going. We got thumbs up from everyone. All right, then in 5, 4, 3, 2, 1,
Let's go.
and we're live.
All right.
So you see downloading the challenge immediately, the name of it is anti-compression.
Anti-compression. That's an interesting hint of a name, if I had to guess.
You know, I think we could all use some decompression after Live CTF every year.
Well, so there's a difference between decompression and anti-compression, turns out.
No, it's anti-compression.
Well, so I didn't write this challenge.
Neither did I. Thank you, Rusty, for
Thank
adding
you,
another
Rusty.
challenge.
But this challenge presents a compression algorithm, and it's opponable, right?
Mhm.
So clearly, there's something going on with this compression scheme.
Well, I imagine it's a little bit buggy, like the right monitor over here. Here we go.
Yeah. So if we look over at Friendly Maltese Citizens here, we can see this binary has some friendly strings in it that give the players an idea. We see that chunk to compress. Also, some friendly symbols here give them an idea. Compress. This looks like, if we're going to trust the symbols here, which I think you can,
I think so. We're not. It's not Loki again.
we usually don't try to put those tricks.
Except when it's very explicitly the challenge. Oh, actually, over here on Shellfish, we see a development. So we heard about Blue Water using an AI agent that they made in order to solve a couple challenges in the background. We
Yeah.
just saw Shellfish editing their prompt for an agent that's running in the background for this challenge.
Yeah, Blue Water making some waves with the debut of a challenge solver.
Yeah,
in
that
the
worked.
background. That worked.
That
Yes,
worked.
yes. And so it's interesting to see what the other competitors have cooked up overnight, because that was live. We talked about it on stream. Everybody
Yeah.
has that information.
We did hear whispers that Shellfish tested out their agent against a couple Live CTF challenges that they did yesterday, and it solved them. I don't know about time frame. I don't know about, if they had to focus on it or if it just ran purely in the background, but, it's kind of promising. We might just be getting a valid solution here from Shellfish.
We'll see. But I like to see that at the beginning, anyways, we're seeing this classic reversing process, and I think that understanding what's going on here, like, this is a pretty simple challenge overall, pretty straightforward. They know it's probably a bug in the compression.
Absolutely. It's a very simple binary. You get the opportunity to compress some data. And if I'm not mistaken, I looked at this briefly, that it's just like a run length encoding. So it calculates the maximum possible size of the compressed output as the buffer length, I think, times 1.33 or something like that, gives base 64 vibes. And then it goes through and actually compresses it, RLE, except I think the maximum output size is 2 times input length. So you get a decent size overflow.
Yeah, and if you're not familiar with run length encoding, it's basically a number that specifies you're going to have a sequence, and then a number specifying the number of times that sequence would repeat.
Yeah.
And so if you can do run length encoding on a byte sequence where you're specifying 1 byte, and the run length gives you a length of 1,
then
then
you're doubling your input length.
you've got 1 byte
Yeah.
that's taking up
And
2 bytes on the output
If
side.
I'm not mistaken, I think I saw a block marker in there for like a chunk boundary in the compressed output of like 0x81. So that could trip up teams, because you're going to end up with not just like your input run length encoded in there, but you're going to end up with 0x81s kind of tossed around.
Yeah, and so I think it's going to be interesting to see how they approach this. I think that a mix of static and dynamic is going to help, because this is, compression is not necessarily the most opaque or the most transparent of things to see in disassembly, right? It's not a standard pattern that you would just look at and say, oh, this is standard compression. At least I don't feel like most people reverse compression algorithms normally.
I feel like it's a niche in a niche that ends up looking at disassembly and is just like, oh yeah, that's RLE.
Yeah. So I think that getting into the debugger and just trying things is going to be a good be a good strategy overall. So, and if we look over on Friendly Maltese side, we could see that they too are starting to build their script.
Well, they're going through and you see them marking up compressed. Well, they already have compressed. They have hexwrite helpers that they're going through and trying to figure out. They are marking up buffer lengths, which you have to do if you want to properly calculate overflows.
Yeah, here we are. This was what I was just seeing. We see that classic Pwn tool style script, which
Yeah.
I think you can see that they've got a template going on. I
Here
think
we
that's
go.
very
So
smart.
alternating characters is going to give you run length of 1 repeating, so you're going to overflow, and you're probably going to hit
Already has an
a
idea.
bad rip in here.
Yeah, yeah, and they got that that length there, that OX400, I believe, from the binary.
Now, is this Jeff or Pwnebag in there? I didn't actually see their GDB helper. I'm always curious to see what people do. I've seen some custom ones, honestly. People
Yeah,
write their own
yeah.
GDB interfaces.
Okay, yeah, we're taking a look.
Yeah, it looks like Jeff. Now, granted, I haven't used that one in a while, ever since they introduced the binge integration. And then I was kind of like, oh, we have a debugger. Alrighty. So we see them just trying to get the offset correct for
let's jump over
the
to
overflow.
Shellfish, because I saw a little LLM magic going on. They flipped away real quick, but and it's always tough. We're doing the best to watch the players' screens, but these players are so fast that
They are. And they know exactly what's going on in their head, and they're flipping back and forth, and they're keeping track of multiple trains of thought, and we're just trying to catch up.
we're just trying to keep up. Honestly,
Yeah.
I think that there's a lot of interesting work just trying to reconstruct someone else's train of thought, right?
No, absolutely. And I mean, I feel like that's we have a little bit of lead in the beginning because we wrote and verified these challenges, but then when they start getting into their actual thought process for solving it is when we just need to assume.
Yeah, and I think that this is a really cool sort of gameism where we are watching what the players are doing, but it would also be cool to have more of an overview to like see all of the windows that they're switching between. Would take a little bit more
Oh,
work.
that would be involved.
It
I
would
don't
take a
feel
bit more
like
work, but I
writing
feel like it
live
would be great.
CTF WM. But well, maybe just get a Neuralink sponsorship and we just get output from what they're thinking.
Yeah, or
Yeah.
I mean, we're just doing our best here with HDMI cables and making it happen. But let's jump back over to Friendly Maltese, and I did see Jeff popping up. You were right. It is Jeff. Their
I
GDB
still know
helper.
one or two tooling things.
Yeah, so it looks like they're rolling through in the debugger, trying to just get those text delimiters set up so that they can rapidly iterate. They're
right.
getting the input length and the output length.
Oh, and then does it actually give you the hex encoded output? Well, I think it does because you have a hex write utility being shown. So I think it gives
They're
you
definitely dumping
full
it one way
memory
or
output.
another.
Yeah.
I mean, even if it just sent you the buffer back, Pwn has friendly helpers that you could just dump that out and hex anyways.
No, it's super nice. Now, I'm surprised. Are they? I don't know if they're running against the remote instance.
Variable name WTF. Always.
Well, but WTF to DST is a great change. That means that they're moving forward.
Exactly. That is the sign of learning in the reverse engineering process right there. When you change a variable name from WTF to something that is not WTF.
It's also nice to see people use different tools in this because over on Friendly Maltese, we see them using Binja, granted 8010, which I think is a little bit old, but on Shellfish, we see them going IDA. That's the name of the binary is patched. They did not patch binary ninja.
Look, I'm not
probably.
I think the stance has always been that if you're a reverse engineer, we
oh yeah,
you think that they might reverse engineer their
tools.
Yeah,
I mean, we explicitly have it in the license that you're allowed to reverse engineer.
All right, here's our LLM shot here. Connect to the IDA MCP server. Explore the binary. Reverse it.
Called decompile function. Oh, so that's the IDA MCP.
Yeah. So so if you're not used to using an MCP server to help you win phone challenges here, the idea is that the MCP server allows the LLM to interact with IDA and get information out of IDA, this specifically being an IDA MCP server.
Interesting. Is it a fixed format that MCP has to return? Like, is it a defined protocol, or is it just kind of ad hoc CTF tooling?
So MCP is a defined protocol, but you can write a server that will respond with whatever you want. This gives you the ability to expose very explicit things, so like disassemble function. So you could imagine think of it as presenting tools that an LLM can use, right?
No,
and you define the tools, you define what's returned.
Mm-hmm.
I'm explaining this for the audience that may not be as familiar.
Well, I've actually never used one or written one.
Here we go.
Oh, okay, here we go. So packet
So
formats.
this
Okay,
is
so it's calling it packets of compression, which I guess is right.
they identified RLE, which
Oh.
is correct.
Okay. Run,
It does not
D3,
seem to have made any comments that
literal packet. Oh, so I guess the marker was 8. Well, the marker might be 8.1 and it might think it's 8.2. So I'm not 100%.
yeah, we'll see.
Oh, no, here we go. 2 packet types, literal OX80 ORed with length.
Yeah, and I think that this is one of those challenges that is difficult to there's some amount of benefit that you're going to get from having AI explain certain parts to it, but if the insight is there's a bug, and if the AI doesn't spot that for you, you could just end up being sort of stuck in a trap of trying to get the information out of the LLM. The LLM never gets you. I think we might be seeing some artifacting on the Shellfish side just because they're switching virtual screens or something like that. So if you see any of that,
I think it's a little bit of cables being cables. Someone
Which-
might have thought too hard about HDMI, and then the HDMI cables got embarrassed.
yes, they're very sensitive.
They are. They are.
All right, let's take a look at Friendly Maltese. They're going through, they're reversing.
Yeah, just marking up output bytes so they're understanding that output to a destination.
But this might seem like it's not making a lot of progress, but every time you relabel a variable, you're gaining information, encoding it into your workspace, and then that is one step towards having a chance to spot something that you may not have seen previously.
Absolutely. And with the challenge that's kind of, I don't want to say straightforward, but simpler as far as interaction opportunities, when you get a solid understanding of the way that the memory layout is.
Yeah, but if you look in the
really
lower left
helps.
here, you already see that they have an idea. They know that having
Yeah,
a larger
input length
output
is
is possible. Yeah, they have
Yeah.
the output length of 2066, which is larger than their input length, but still not large enough to overflow the buffer if we
So it looks like now
have
they're
our
going
understanding.
to continue through, try to get an exact overwrite. And they're going to probably keep adjusting the number of times they repeat this A-B pattern until you get, an invalid rip or a crash.
Yeah, and I think that if we look over at Shellfish, they have a very similar pattern where they're starting with A's. They're flipping back and forth very fast here on the screens. So yep, they're doing A, B, A, B. So
Okay.
this is
So they both
very similar
absolutely
pattern.
know that it's RLE.
Yeah, I think both players are in the spot where they have an idea that this compression can lead to an overflow. They're just trying to dial it in.
Mhm. And I'm actually going to try to fix Shellfish's flickering issue right now. Sorry to leave you on your own. It'll be
That's
just
all
a
right.
few seconds.
Go be the hero, Josh. All right, so let's both competitors seem like they've got a bit of momentum. You can see it in the pacing of their cursors. They're moving quickly, flipping between windows. You can tell that they feel like they're almost there to the next spot. I think that they know what they need to do on both sides. It's just figuring out exactly how to dial that in. So this is exciting. This is where it comes down to neck and neck. Who's going to make that next insight faster? Who's going to get the overwrite and start to really proceed to getting execution?
Couldn't agree more.
Well, welcome back, Josh.
Thank you.
So, as I was saying, we've got both competitors have the momentum, just working on their scripts, dialing in their overwrites.
Gotcha. All right, so just continuing through, I am interested to see that no one has tried just encoding like random bytes. Or
Well-
just like the fixed bytes, beyond the point where it will overflow. I'm not 100% sure if there's some bounds checking on compression output that might be preventing it, or if it could be, they just see the way forward so clearly that now they're just working with what they know.
Yeah, well, and a little bit of this can be luck. Like I was talking to Carl earlier, who did the test solve on this, and he said that actually using a cyclic pattern as his test buffer triggered the overwrite.
Oh, it absolutely would, yeah.
And so, that's a bit of luck here, and it's interesting to see that both of our players here are trying just the AB over, which is,
Well, it looks like
straightforward.
they're immediately identifying that it's RLE, so they just know that, okay, if I switch characters every time, or every 2 times as we've
Right,
seen over
right.
on Friendly Maltese. It looks like they're trying to understand how the run length encoding, well,
Yeah,
run
I
length
think
encoding, the run length is encoded.
I think so. So right now they know that they've got a pattern that causes that sort of anti-compression, if you will, and they're just trying to dial in that right. And there's a bit of math, right, that you're trying to figure out. It's like, okay, my buffer's this big, that my input is this big. Exactly how far do I have to go? And that's what cyclic patterns are for.
Oh, absolutely, and it's really nice. Bone Tools has utilities. I feel like we're an ad for Bone Tools at this point. Bone
Well,
Tools has utilities to find offsets in cyclic patterns where certain things show up. So once you get an invalid rip, you don't need to keep adjusting and jiggling back and forth. You can just be like, hey, Bone Tools, where's this?
well, let's be clear. I think that there is no question that having a strong set of helper tools and having a cohesive tool set that allows you to be adaptable and tackle different challenges, that is the winning strategy.
Oh, absolutely. If you're familiar with your tooling, you gain so much advantage on just the overhead of interaction
Yeah.
because you see these competitors going back and forth between windows. We saw new tooling be introduced with the IDA MCP on Shellfish's side. We see Friendly Maltese being very comfortable with Binge's interface. Just like having to switch back and forth between tools and writing script and interacting with challenge so much, getting rid of a little bit of overhead on each switch will really add up over
Yeah.
even just 35 minutes of challenging.
And really what Pwn Tools is, besides just a tool set, is a flexible set of primitives that you can put together programmatically, and that's what gives you the flexibility. So to put this in contrast with some of the AI tooling that we're seeing right now, we're seeing the first step towards integrating those tools, which is toss it over the fence. And maybe it works, and if it does, great.
Mm-hmm.
But if that doesn't work, the player doesn't gain any real benefit, right? If the AI solver solves it, they win. But if they don't, they
Now,
don't. There's no feedback to the player. Really.
I'm very curious to see because we saw in Blue Water their solver submitted also, which is
That's what I'm saying.
that's how we mark who won the challenge. Shellfish, I don't think they have a submitter hooked up.
Right, right. So they're in this case, that is, it's an LLM hooked up to an MCP server. So in that way, the purpose of that tool is to help them make the solve.
Yeah, it's less automated, more an assistant.
Right, and so I would consider those two separate toolings. One is the assistant that's going directly for the solve, and the other one is really just the sidecar assistant.
Gotcha. Yeah, now there are upsides and downsides. Upsides with using interfacing assistant is you don't get, well, one, your compute resources and battery aren't drained like we almost saw yesterday. Someone's battery died
Oh,
from running
no.
MCP. But you get a lot of back and forth, and you can gain a better understanding of the challenge when you're actually interacting with your agent versus, actually having to interact with it. It's
Yep.
not just working in the
Yep.
background.
Yeah, and that's I think so. I think the next logical steps are improving that MCP style, like giving the agent access to your information. But then perhaps the step after that is, can you have the agent watch what you're doing and make recommendations as you're going?
I think that's eerily similar to having live CTF commentators watch what you're doing and make recommendations. Are you
I-
trying to say we're going to be put out of a job?
Ooh, I don't want to think about that, but I'm not going to deploy
That's
to everybody's
the real
laptop.
challenge.
I'll just say that.
You're not going to watch everyone's laptop at once? Oh, come on. What do we pay you for? Oh, wait, we volunteer.
Nobody's paying us.
We pay to be here.
Okay, it looks like Friendly Maltese is they seem like they're making progress. I mean, I don't see a lot of change to their byte string, but they've been continuing to gain insight. They've been changing up their script here and there.
They have. It looks like they were expecting the return address to change there, maybe. I'm not 100% on that. But I see that it looks like control flow is still normal, as far as I saw from their
Right.
Jeff output.
Yeah, I didn't see any register overwrites or
Yeah, I didn't see any
stack
4142,
address.
4142 in there. Well, I
Right.
guess it wouldn't be because it's our lead. So correct me if I'm wrong, but the intended solution for this involves creating a run length of what you expect. So essentially, if you want to jump to 414243, right? You'd create a run length of length OX41 of 4243. I think.
That's a bit of a mind twister right there. But that's a great question. I follow you logically. I
Yeah.
did not look at the reference solution for this.
Well, that's, I'm just not sure. Oh, well, I guess you need to push off because there is that chunk end marker, so you need to get the alignment just right. Otherwise, you'll end up with that chunk end marker in your address that you're overriding with.
Yeah, I'm really excited to see what these players come up with, and I am fingers crossed that we're gonna see a solve here. I feel like
I think
my hint senses are tingling.
your hint senses.
Is it about that time?
Well, I'd be able to tell you as my Discord app is opening. It's like hint senses, but much lower tech. Yeah, a hint in 1 minute. Oh my god, your hint sense is spot on as always.
Highly honed.
After years of training. So the hint will be releasing within the minute, and that means hint 1, hint 2 will be coming out 15 minutes later. Now, I'm unsure if hint 1 is going to help these teams much. I haven't looked at the hints for this challenge.
I'm
but
guessing
I think
that
hint 1 is just
something
it's
like
RLE, guys.
It's RLE. Yep.
Yeah. So
I think that both players are beyond the point where that's really going to do anything.
And
for
I
them.
think both teams aren't losing much from not checking if there's a hint release. I think they both know the way forward. They both see the path that they want to take. We do see a lot of dynamic iteration happening over on Shellfish's side, though.
Yeah, so it's curious. It looks like they're rolling through. They're providing blocks of a changing character there, so they're encoding. They're rolling through a range of bytes, and then sending that. So we see a pattern there, and that's what I'm just saying. It's curious that they haven't. We're not seeing an attempt of a cyclic pattern use.
Yeah, it is interesting. I do think that. Well, I'm not that familiar with
But perhaps
cyclic generator.
I mean, my initial impression was that perhaps these cyclic patterns wouldn't be enough to create an overwrite. And
it absolutely would.
It turns out it is, right?
Yeah.
But if you thought not, then you probably wouldn't try it. And
Fair.
that's one of those things where if you don't think to try it and you do, if you just try it out, it doesn't cost you a whole lot to use that as your buffer.
Mm-hmm.
You potentially make this big leap forward.
Well, personally, I find that making explicit patterns in code rather than relying on cyclic generation kind of helps me build a better mental model of the memory model that I'm interacting with.
Yeah, that's
even
very
though
common,
cyclic
right?
patterns are really nice for kind of automated finding, it's a CTF, so once I get the offset, I get the offset.
Right, and so that's what we saw over on Shellfish's side, is that they were trying to create long strings of each byte in order to see what it looked like on the compressed side.
Yeah.
Whereas Friendly Maltese, I don't think I've seen them mess with their byte pattern here that they've been sending, but it looks like they're dialing in a pad right now, or it looks like they're trying to.
Yeah, it absolutely.
They're trying to
looks
nail
like
that return address over, right?
Here we go. So yeah, they're going to be trying to get the right offset here. You see them
Yep.
inputting YZ run length, so they're trying to shift over their.
As you said,
you're going to try to see YZ.
Yep.
In the return address here.
Yep. And so there's the return, with just creeping up to the return address there. You see the.
Yeah, I think are they just 8 bytes off? Do they know exactly what the offset is?
I think they've manually dialed this in, which.
Nice.
Yeah. But this is really interesting too, because they use, we as CTF solvers use these visual patterns to give us an idea, as you said, of blocks of memory and how much can we write, can we control this. I mean, I remember long ago dialing in stack buffer overflows where it's you start with all A's and then you call out which registers you control by setting B's, C's, D's.
4 B's.
Right.
That was
B's,
before we had 8 B's.
Yeah. Before the use of De Bruijn sequences was common practice. That's what we did.
All right. So they're returning to a null byte region, it looks like there.
So what we would expect is that they're at the point where they're trying to control their overwrite. So the first step is figure out the padding so that you can control that overwrite, and then the next step, as you said, was how do I put the bytes that I want to be in that return address at that spot on the stack.
Yeah, absolutely. And it looks like they're breaking right at the ret, so they're getting very close. Over on
I think they're right
Shellfish,
there.
we can see that they're looking still statically here. They're making sure they're probably statically calculating the offset, if I had to guess.
And that's why I say, like, both of these competitors appear to be doing the math manually, which is totally valid, and I think that they'll get there with it.
Yeah, it's not very complicated math. It's what? One addition, one division.
I mean,
So
it's still difficult.
it is still difficult, absolutely.
And I think we're
But-
seeing the output length over right here, because output length 64355. That
Yeah.
doesn't seem right.
No, that doesn't seem like very efficient compression. Maybe we should fix this challenge.
I don't think that. So yes, there's a bit of anti-compression here, but it's not that much.
No, I mean,
that's-
what, 812 to a couple, what was that, zettabytes? That'll download
Yeah,
over fiber in, what, an hour?
Yeah, that is clearly requires a 64-bit integer to communicate that
But
number.
we see them here setting the win address, storing the win address here, and they're just going to
Yep.
send it. And
Yep.
this might actually be a solution coming from Friendly Maltese. I'm not 100%.
If this works for them, they'll pop a shell right here.
It's very possible.
All right, so they're stationed at the return address. They broke on the return address. They're looking at what's written there.
Okay, and then setting.
So they're going through locally to make sure they have this overwrite controlled. And
Okay, so they might be on
that looks like the
way.
normal return address.
Oh, you know what? Well, it's going to be compressed. So you need to write the pattern that compresses to the win address, not just the win address.
Yeah. But they're right there. They're figuring that out.
They are right
now.
there. So I think we might be seeing a solution come in soon. Shellfish going through and marking up very well, actually. The
speed
variable
with
names
which
here.
they're moving through this decompilation right now, you can tell that they're very familiar with the structure of this challenge, and I think that you can sense the urgency in just their movements.
Oh, absolutely. And I mean, the muscle memory for tools is really taking over here.
Yep.
Like, I was talking with someone yesterday, and they come up and they're like, "I'm so sorry, I use IDA." And I'm like, "Don't be sorry. That's what you know. Like, you can work efficiently with it. Use whatever tool works for you."
Yeah, I mean, at this point, if you've been using a tool for years,
Yeah.
it's an investment to learn a new one, and that's why I don't hold that against my friends that use IDA, even though I've been a long-time Binger user.
Oh, well, shucks. That's why I don't hold it over people that use Emacs.
How many holy wars can we have in this stream? All right, let's.
All right, so it looks like Friendly Maltese. Oh my God, Friendly Maltese. Okay, they just ran
Looks like
through
they
and
just
won.
nailed it.
They
Yep.
just changed
So
one
as we
offset.
saw, they were right there. We knew that they were right there. They were right at the point where they were controlling the return address. So
Yeah, and
naturally,
they really
not
just did
much
one little adjustment.
of a step
landed
there
the win.
to get to the next one.
Nice.
All right. Well, that was an exciting challenge. I think that was perfectly paced. I love to see the progress there, and
Absolutely.
I don't think that I saw a whole lot of help from any LLMs in that challenge.
No, it looked like Shellfish kind of left the AI agent after just a few minutes in, after it started hallucinating, as you'd expect.
Well, either way, I mean, I like to see that they're trying new tools. We saw the integration of an MCP server in this one. Sorry? Oh, very
Oh,
interesting.
So the final match is going to be an.
So last year's finals, the final match of yesterday
Was Blue Water versus Maltese. And the finals is going to be
Blue
Blue
Water.
Match versus Maltese. So it's going to be a rematch,
rematch.
of yesterday's last match.
You know, and that's one of the interesting things about our bracket. If you haven't checked out the bracket at LiveCTF.com, scroll down. You can see the whole bracket. Since it's double elimination, that's totally possible where you get a redemption arc for Friendly Maltese citizens. I'd love it.
Oh, absolutely. And we saw actually Shellfish making it this far after beating MMM earlier in the bracket. Correct me if I'm wrong, but I believe they've met 3 times in the past. MMM
Ooh.
taking the win every time, and then Shellfish, Kyle Bot beating Jinmo this year.
Wow, love it.
Yeah.
If you haven't been following all along, trust me, these players are amazing. The history goes back. Just love to see it.
No, I really like it. And in this challenge specifically, we saw a lot of static versus dynamic approach here. And I think that this challenge was very suited to a dynamic approach.
Mm-hmm.
And we saw that it wasn't necessarily something you needed to understand a large amount of foundation of. Once you understand the bug, you can leave a lot of assumptions in place until you start adjusting your offset.
Yeah, great challenge. Great job by our competitors working on it. And
And we'll
finals up next.
Yeah, finals up next. We'll see you back on the hour, hopefully, for the final match of Live CTF at DEF CON 2025.
Outstanding.
I
Till
think
next time, CTF
This is
fans.
our last time casting this
Yep,
year.
yep.
Oh my gosh. Well, it's been fun. And yeah, we'll see y'all soon.
See you around.
Hello, everyone. Welcome back to LiveCTF. I'm here with Jordan. I'm Zeta2 or Carl, and we are here with finals.
This is the last match, and this is kind of an epic one. This is something that's never happened before. We have the man versus machine final. We have a bot. Blue Waters has had, I mean, they have a great CTF player too.
Yep.
But they also have a bot that they've been very successful. Oh, that was a nice bandwidth test.
Yeah.
They have really good bandwidth right now, it looks like.
Yeah.
But they're both ready. We're going to go ahead and count them in so they can get started on this
Yeah,
challenge.
and then we can talk more about the
And we'll
whole
talk more about
the
what's
storylines that have been
going
unfolding
on.
and so on.
So, once we get the thumbs up from everybody,
Yeah, we have.
and we'll
progression.
count
5, 4, 3, 2, 1,
go.
go. Oh wow.
And it's a race. Okay,
Yep.
they got the binary. That's good. No hyphens versus underscores.
No technical issues. Like,
And
I
there
think,
it is. There it is. We just saw that. This using that as the so there it is. It's launching the bot. It's launching IDA, and it asked them to use that binary. So that was the bot over there on blue. Wait, we have this backwards, I think here. So it's blue water was there, and the friendly Maltese will be over there using Ninja.
Yes,
All right.
exactly. So just to introduce the team here, as Jordan said, we have in the final here, we have Blue Water against friendly Maltese citizen. Blue Water have come into this undefeated throughout the, they come through the upper brackets.
Oh no, there's a bug in their script.
Okay.
Wait, is it already solved? Okay, you could see them SSHing in. I also saw a Devon string there, or something like that. So just an interesting bit of a string that we saw there.
I think they say maybe they're having issues with cap because this challenge has an extra library. It uses libcapstone as well.
Oh no!
So maybe there could be some
Their script
issues
isn't
there.
loading it.
Yeah, so you see they're doing some changing their LD library path and so on. So they had some technical issues there. Over on FMC side, we have the binary open in Binary Ninja. And you can see there were some strings there. Welcome to the glitch emulator. And this function here, you have the fancy sacrificial routine. Basically, it's like an allegedly safe version of the getS function.
Okay.
Which is, notoriously unsafe.
Yeah, out of the box.
Yeah. And here, Glenn, who built this challenge, has created a safe version of this. But then you're allowed to provide up to, you're providing 8 addresses. And at those 8 addresses, you will knock out the instruction at that address, which will then turn the safe function into an unsafe function that you can exploit.
So straightforward in execution, and this is one of those. I think I'm going to stop making guesses as to whether the AI can or can't do something at this point. Since that was so blatantly wrong last time.
I'm going to say that I believe that this one is tricky for the AI.
Okay.
That's
okay.
Because I think that we've saw some previous examples. Also, just to bring them up again to speed. So Blue Water, apart from they have some kind of autonomous agent also working in the background. So it's almost like a 2-on-1 situation here. But anyway. The challenges we did see them solve, for example, the stack-based VM. My feeling is that one, it's enough with like kind of broader strokes analysis. You can kind of like squint and see like, oh, here are the operations and and so on.
And we did see even in the prompts when people copied and basically decompiled code, the AI, even just the chat models, were pretty good about identifying. Oh, okay, it's using obfuscation control flow. It's got some opcodes. Here's it seemed like they were able to kind of pick that up.
Yes.
This one, I think, in terms of like the challenge design, is not very hard, but it is fairly unusual, right?
It is
like,
a bit
this
unusual,
is not
so they might not have seen this stuff before. Also, it's very precise. Well, I mean, there could be multiple solutions. We have one reference. Well, we have 2 reference solutions, which I believe are identical. We both came
in parallel came up with the same solution, right? So that's what we mean by precise.
There could be different ones. But the thing is, like, you have to really carefully analyze the data flow throughout the assembly instructions.
We are seeing real quick there a checksec on the binary. So again, we do have so there is a bot running, and we might literally just see a solve happen in the background. Now, if we do, we've already got an agreement. We're going to go over there and talk to the author of it, and we're going to get a little bit more information. They're not going to share everything about it, but they're willing to talk about what the script was, how it solved it, and so we'll get a little bit more information to kind of make up for the fact that the bot is sort of in the background. But we're still manually doing it. We're still reversing it in IDA. We're still calling checksec. And
here they are looking at this safe gets function, which is basically what it's doing is it's mapping 2 pages and then like one read-write page and one
executable. Assume?
No,
Oh, no.
not execute. One like guard page.
Oh, okay.
And then
okay.
you're doing the gets into the thing. So if you overflow into the guard page, which will cause a seg fault, but then you catch that seg fault and you return from the function. So this way you
That's
implement
the safe implementation.
Yeah.
I gotcha. Yeah.
So this is
And that's had that message right there. Well, it's seg faulted, but we caught it. That
Yep.
makes sense. So they're implementing that.
yeah. So this is the design of the save function.
So now when you write, you said you write NOPs, right? The challenge lets you write addresses. You give it addresses you're
Yep.
going to NOP out. In fact, we can even see on Friendly Maltese, they've got a leak, it looks like now. So
yeah,
they're
I
just
think
doing
the
leak.
binary just prints. We like to do this sometimes. To simplify some of the challenge, we just print out like a base address or something like this. So that's what they're capturing.
Especially when we know we're trying to solve it in under an hour. There's only so many things you can make them do. You know,
Yeah.
in a regular challenge, they would have to do multiple bugs chained together
Yes.
potentially. But
This one also has a win function. That's
Yeah,
also like
yeah,
instead
another
of having
common
them to do like ROP. So it's basically like, sometimes we just decide to take away some of these kind of like standard steps. Like, we don't have a bug for a memory leak. We just print the stuff. We don't have them do
write
a
the
full
shell
ROP
code
chain.
or do a full ROP chain.
Yeah. So we might just kind of like skip those part of the challenge.
And that's just to make it sort of bite-sized, digestible, something that can fit within our little 45-minute time limit that we're going for.
Yeah.
So fancy sacrificial routine, and then back over here on Blue Water, we've got, which function are we in now? We're still
They're
in main.
also looking at this. I think, once you kind of understood the big idea of this function, you really have to drop down to the disassembly and not look at the
Which
decompilation.
what we're looking at already over there. So
Right.
FMC is already looking at disassembly, which
Yes.
makes sense. Oh, and they're already
Actually,
writing.
This is actually very
Yeah.
interesting.
Are they already looking for values to knock out?
Yes. So I'm trying to remember which instructions I removed when I test solved this, and this is
And when you
It's-
move
it-
instructions, do you have like you write a single byte NOP? You write
no.
you give it an
it's-
offset. of
That's why you have
instruction?
libcapstone
Ah,
in this.
it knows the width of the
Which is also you
instructions.
cannot do. I believe you cannot do like in middle of instruction thing. You have
yep.
to like you have to do like
Just whole
actually aligned,
instructions.
and it's the
Yeah.
whole instruction. so
Which actually makes it easier on them in some ways because you don't have to even consider weird, screwy
Right.
partial matches.
right,
and like,
exactly. That's
You know there's a solution. It's in a CTF, and you
Yes.
know it must be at function boundaries.
yeah. I
or at
mean, in a
instruction boundaries.
sense, I guess you could actually. Well, okay, that's
You
a
could-
big. I'm thinking like because also another thing, you can only NOP inside this specific function. Like you
yeah.
can't do it like in the main function or
Also
other things
keeps it
around.
kind of
So you have it constrained. So I was just thinking like how many assembly instructions are and what's like the n choose
Combinatorics
8
of-
but I
yeah.
think it's still quite big.
Oh,
yeah.
there we go. So we've got some nulls. It looks like I just saw a bunch of D references.
Yes.
So
they are-
yeah, and I think a debugger is a great choice. You are going to spend a lot of time. You want to see it in the debugger.
Uh-huh.
You want to see after you NOP it out, like to verify it. Although I will say the Binja patching might be nice for this too, because they can in Binja very easily just quickly, literally with a single hotkey, patch out its instructions to look at the analysis
Yep.
to see kind of how it works.
So basically, the way you do approach this is that, as I said, like this gets function, it maps a page and so on. But then to actually get the result, so you provide an input buffer to the function, and then after it runs, it copies the result over to this buffer. And the idea there is that if you NOP out things in the right place, you can have like the gets go into this original buffer and just kind of not go into this safe page.
Oh,
And
yeah,
so,
yeah.
so you just kind of reduce it back to a regular get
Unsafe
S call
gets,
to
yeah.
a stack buffer, and that's how you win.
That's certainly one way. There may be others. Again, when you give
Yep.
teams this much control, you don't know for certain.
Yeah.
So we did just see, there was a full screen of A's there. So again, the Blue Water player is still doing this manually as well. They're not relying on their bot to be the only thing that solves it for them.
Uh-huh.
In fact, we're going to have to go back and check the history and see the earlier matches. I think they were the one that solved their first couple matches. I think it was only that we were surprised because we saw them still hacking, but then the bot had done the solution in the background. They didn't even notice it. So
Yeah, and they've been playing matches. So the way we're running this tournament is like we are streaming and commentating some of the matches, and then we had some other matches on like a parallel stream without
Yes.
commentary.
yeah.
So sometimes you're like in the spotlight, and sometimes you're a little bit less in the spotlight.
Now, certainly from here, if you're just looking at these two teams,
Yep.
FMC is far ahead, right? I mean, if you ignore the bot,
yeah,
we just saw the beginning of the solve script. We haven't
believe
gotten any
so.
leak. We haven't gotten any, particular offset override. So it looked, and we saw them looking early at the disassembly more.
Yeah.
So if I had to guess, I'm guessing FMC. But again, it's hard to know for certain. And of course, the bot's such a wild card.
Yeah.
I will say we did have that interesting last round where Shellfish also wrote their own bot, and actually fiddling with the time with the bot at the beginning actually put them behind. Like I think it actually cost them a little bit.
And moving over to FMC, you know, you said far ahead. I think
Well,
ahead.
ahead is safe.
Yeah,
Far
ahead-
ahead maybe is not.
Yeah, but it's also this thing, right? Because you know, let's say you get kind of like you because there are many paths here.
Yeah.
And you might start going down one path, and you think that like you can like, oh, if I have this, and if I just fiddle with this one step more, I can land it, and then you might be like in a dead end, right?
Yeah.
And like for example, now they're looking at this like signal handler and stuff, and well, I mean, sure, there might be a solution there. Again, we don't know. There might be multiple
But that's
solutions,
not
but
the
I
intended
don't
one.
think any like the signal handling stuff is that's a red herring.
Yeah, and we did see. Well, they were looking at disassembly, but they were looking at it, I believe, and still just main back over on Blue Water. So just watching what they were doing. They, again, we sort of use that as a hint that they are looking at places they could see as targets to overwrite. So they just or maybe they were just checking the decompiler output. It's hard to say for certain.
Yep.
But there we go. Right. See, now we're looking at will it seg fault? Like, so we are looking at now. You said that you can write knobs. Can you write them in main? Can you write them only in the gets?
No,
Where is it? That
it's
you can
it's
write
only
those?
in this sacrificial function.
Okay,
So there's like
okay.
a memory range. Like, you have to be within that function.
So when we see Blue Water looking at the disassembly there, none of those are, if they're in main, those are not targets.
Those are not
for,
relevant. Yeah, exactly.
For the actual disassembly. So
It could be like, of course, it could still be relevant if your exploitation path for some
What-
reason
yeah,
involved
yeah.
kind of like jumping
back
or like
into
yeah,
using
and then you
some
need
piece
to
of
know
code
yeah.
for sure.
But like they will not be the targets of the actual knobs themselves.
Yeah, and I also want to point out we knew obviously yesterday that there was a bot in the mix. We didn't change the challenges. We didn't change the order. We didn't modify. This is still the game from a game. Yeah, go ahead.
Yeah, and I just want to point out here on the FMC side, you see there's a list there of adders, and you see 8 addresses. So they have set up this thing of like the kind of interaction with the binary. So they have
They have
this
the,
list.
the skeleton, the framework.
Exactly, and
to
you
be
can
able
see
to-
like the first 4 or so they are like the same, but then the last 4 are different because you have to provide 8 of them. So like
Okay.
you start with
so
just
they're building
saying
their payload.
yeah.
Back kind of bottom up or
right,
from the back
exactly. So
forward.
you just like start and like this is I'm again like I don't remember exactly what offsets I used, but it's like vaguely familiar, but that may or may not mean anything.
It's hard to memorize also.
Yeah.
Yeah, we'll see if they
No. But here, look. They're looking at. You see that they look at there was like a move RDI something before the gets, and this is relevant.
Yeah, the argument for
So you
the-
want to follow that. So basically, if you do kind of like a sync, like a source sync analysis, you start at the gets call, and of course, because of the calling convention, the argument that you want to control is in RDI.
okay.
And if you just follow like RDI, if you follow it backwards, like
Yeah.
where did RDI come from, and then okay, it came from RAX, and then you kind of do like a meet in the middle almost, like you see the value of the
Which ones can you modify by
right.
your knopping?
so it's like what registers in the beginning of the function.
We do have Reiko. So if you look now, we're over on Blue Water. They are looking at their offsets in the sacrificial function in disassembly view, tracing it down forward. So they clearly are in the right path right now, right?
Right.
Looking for those places they can overwrite. Again, just in terms of, yeah. So they're putting together a list of where they want to do ops. I didn't see a leak. Maybe they don't need the leak.
You do need the base because those are just offsets. So you need the base address.
Okay.
But the leak is literally just the binary
Sure,
just prints
so-
it out. So
so-
you just need to have
just
to add
housekeeping
that. Yeah.
to do that.
Yeah. So what I was saying with like the exploitation strategy, I think, is like you do kind of like a meet in the middle thing where
Yeah.
you know that in the beginning of the function, the buffer that you want to overflow is in this register.
Okay.
And then you want it to end up in the RDI register. And then you see like what registers at what point contain that address, and what, if you go from the other directions, what register will end up in the destination. And then you can like see if I strike out these instructions, then I can like have these paths, these data flow paths meet.
Yeah.
And then
In the
you
middle.
basically connect it up.
I also wonder, this feels like something where, the AI right now that's running for Blue Water has to one-shot this. It either succeeds or it fails,
Yep,
right?
yep.
There's one spin up at the beginning and then off it goes. And so I wonder if, like, there may be problems it can't solve that way. Whereas on the other hand, if it was truly kind of like cyborg automated Centaur, there would be the ability to describe that problem you just said. Maybe that problem is tractable. Maybe that's solvable. And so, you know, but it makes sense in the game like this. You can't be, you kind of have to go all in, and like really be only using the AI, which point you're limited by it, and you don't have, you know, your manual steps you can easily do, or you just fire and forget, and then it either does it or doesn't. So we'll see which end it ends up being. All right, so we do have a full list of NOPs. We've got the leak. We're pulling out the PyBase, so we're calculating out our addresses. So
and
we
these
have a
are
payload
8 different addresses.
Yeah, that was very quick. So
I don't know if that's like
if it is actually a real fully functional
or if
attempt.
it's just 8 different addresses. I mean, are these just 8 arbitrary addresses, or is this actually intentional, basically?
Yeah, it was very fast to come up with a solution if those are all 8 working ones. If they could do that from what we could tell in a very short time period.
And we can see.
So right, gonna get some shellcode, right? I assume here, or cyclic pattern, sure. Yeah, so this is a De Bruijn sequence or a cyclic cycle used a lot in exploitation where you don't want to have to do math or look at your disassembly. You just want to send in a bunch of data, and if any of it overwrites a register or instruction pointer, you're going to get a crash, and from that crash log, you can look at it and figure out exactly what offset. So it's just a kind of quick hack that's used quite often. We've seen it many times here on LiveCTF.
It's basically a pattern where, in the way this is usually constructed here, it's like if you take any 4-character subsequence of this pattern, it has a unique position in this. So if your value at a crash is
and then there we go, we saw the cyclic find. So they got a crash.
Oh,
so
they got
the
a crash. Wow,
they at least got register control. This could be it.
Is it?
This could be no bot win, but this could be blue water. I mean, and they're looking for the win function. So there we go.
Yeah. Okay, so here we have something that looks like a solve, but this looks like a manual solve then. I'm just looking at FMC. They don't think
I don't see FMC being this close.
I think if I remember correctly, it might be that you have to jump into like the middle of the win function because of stack alignment.
Oh, interesting.
And that may or may not be. Yes, you see this XMM instruction crashes, which is your which means that the stack is not 16-byte aligned. But this is easily solvable if you just jump to after the push instruction.
They were just looking for that.
Yeah, so you just jump after the push, the stack will be aligned, and then this. Well, that is a solution.
That looks like
so we're gonna have a win here from Blue Water
without the bot
opening, and something is not working. But they had a local solve. Oh yeah, they had the wrong port. Maybe they copied incorrectly from
a previous one.
Yeah.
And I don't see FMC going to do it. It looks like Blue Water. It's ironically their bot got him to the finals, but it looks like their human's going to get him across the finish line.
And then.
Oh no, they're going to be so stressed. They know that they don't know it, but they've got time. I don't see FMC as well.
Okay, and is this? That's a shell, right?
Yeah,
yes, that is.
Congratulations, well done. And we don't even have a bot solution to take a look at, I don't think, in this case.
Wow.
Because it was all human done. So there you have it. It turned out that it was a man-machine hybrid that it took to win the competition.
Yep.
Congratulations to Blue Water. That was fantastic. Great solve. Just before the first hint even, too. So.
Yeah, a very, very good timing on that one. So that means that this is it for LiveCTF from DEF CON 2025. It's been a great tournament. We've seen these teams competed, and then we're going to see the placement of these teams is going to be converted into points, which gets added to the main CTF.
Yeah, so just for a brief summary, last time I looked at the scoreboard, first place was MMM with about 600,000 points. The next team behind them was Blue Water, and they were behind them by about 130, 120,000.
Yes.
But the LiveCTF #1 team, which is now Blue Water, is going to be getting 133,700 points.
Yes.
However, no one in LiveCTF gets 0 points. The lowest placed team actually will get you 50,000. And then because MMM went out at rounds 7 and 8, the network broke. Oh, the agent did actually solve it. We're getting a report that the agent did solve it. Does he want to talk about it at all still? Or like, if you like to talk about it, we'll still bring him on to talk about the agent.
If so, will you go over and
if he's willing, I'll run over there real quick and do a thing. You can.
Yeah, we have the screen back here, and then so if you move over, come over there, bring the microphone, and we're gonna get that sorted. And yeah, so we are going to have a short little interview with the player from Blue Water who has been competing with this AI system in the LiveCTF tournament, and we're just getting that set up. But yeah, in the meantime, thanks to everyone watching. I hope you have enjoyed the show that we put on. We've seen some really impressive performances from these players, and it's been really cool to see different techniques, different tools.
Hey everybody, I'm gonna.
This year, a lot of AI in the mix. Maybe not that big of a surprise, but I think this is kind of the year when the technology got sophisticated enough to allow for this. And I am just checking if we have an okay from.
So Carl, yeah.
Every single match.
All right, we're live recording now, and we've got your screen on the stream. So if you want to if you just want to like either click this on or hold this, you can put it on.
I
here.
can hold this, yeah.
And just kind of walk into first. Congratulations, well done.
At least a human one.
And it was well, we were debating like, what would be cooler, but I think it was great that you had both, and it was like a combination of man and machine that won. That was great to see. So we have your screen up, and we can talk about your kind of solution.
Yeah, I guess I can look at kind of one of the solves maybe. I
I'll
think.
just flip on it real quick.
Yeah, so I guess the reason it didn't work is because the forwarding I had from the remote to the challenge server broke, so it
So
couldn't.
do you know how long it had a correct solution? Like how much it would have beaten you by if it
The
had
fastest one I found was 440 seconds.
4 minutes and 40
No,
seconds?
7 minutes.
Okay, oh, it's at 440. I see. So
440
on this particular,
Yeah.
and so you said the fastest, meaning you have multiple. So like you're spinning
Yeah.
up multiple ones,
Yeah.
and they're trying different. Now, do they have different approaches, or are they just like because random in
It's just 'cause
LLMs,
LLMs
you don't
are
know what
random.
you're gonna get?
Yeah.
Yeah, very cool.
Exactly.
Okay, so yeah, so what are we looking at here?
I guess we can look at this guy. So yeah, it's the same solution as me, which is just like knopping out all of the RAXs, I think.
Yeah, and I think that may have been similar. So I didn't actually see our reference solution, but I know it felt relatively constrained. Like there was because there was only a few things.
Let's see.
So it did beat you by almost 15 minutes then, like
Yeah.
12 minutes or so. It's so fast. That's what our concern is like. We'll see if it has this
Yeah.
killed speed hacking or not.
I guess
The AI is going pretty good.
unfortunately the traces are really hard to read, but yeah.
Well, and to be clear for the audience too, like early on, you had asked like, can I run something in the background? Can I solve it autonomous? We said, yeah, that's within game. But we
Yeah.
did also want to kind of see some proof it wasn't just another human,
of course.
even though we were pretty sure like 5 minutes solve, like no. If you had
Especially
something that fast, you'd send it
the
here.
reversing one yesterday, I think.
It-
was it the reversing?
The PNG one.
The PNG
yeah, that
one,
was
yeah.
so fast that we just felt like it had to be.
I was quite surprised by that solve.
Yeah.
And then what was the second challenge?
The
yesterday?
exception, the other one that just solved
Oh,
was
the VM one?
Yeah, the VM
so
plus
the really
exception
cool
handling.
thing about it was
Yeah.
it read it, then it realized it was a VM, so it wrote a disassembler,
Amazing.
and then it disassembled the VM.
Yeah.
Then it wrote Z3 constraints,
Okay.
and then like got the SAT and got the flag, and then connected and like
crazy.
solved it on remote.
And it did that in like 15 minutes or
Like
something.
5
right?
minutes.
Or five,
No.
no, the second one I think was a little longer.
Oh, it was
if I-
really long, yeah. I
Yeah,
don't
but it was
remember,
still fast,
Yeah,
maybe
it was
12
pretty
minutes or
fast.
something.
Yeah.
So yeah, we are streaming live. If you want to, by the way, help us stream, you're welcome to do it. But so the camera's over there, but we're showing his screen now when we talk through this stuff now. So
Yeah.
we can bring it back. Yeah. So we've got the log of so when we saw this log, we were like, okay, clearly this is a real
I mean,
solution.
also like the exploit, like the kind of code it writes is not like human.
They have so many comments.
Yeah.
They like comment every single line. It's very obvious when an AI writes
Yep.
something. And no matter how much I tell my prompts to like not comment the code when it's
Yeah.
obvious, like they're full of comments anyway. So yeah, so I think the log makes sense. So you have some sort of like reasoning approach, just kind of in general, right? Like you have to have some sort of feedback. And
Yeah.
like, the nice thing in this case is there is an oracle. You have a binary.
Yeah.
And if you can run it, how much? I mean, do you have to do a lot of work in terms of setting up like giving the like different tools to run or Docker or Crunchy? Oh, it might be.
Oh.
We can also just use this.
I mean, can I just do this?
Yeah, that totally works. Yeah, we'll
Okay,
see if that works.
Yeah, I think the hardest part is kind of giving the LLM a sandbox environment,
Yeah,
like so
yeah.
that it can just test things in a loop.
Yeah, because it
uh,
has to do that. It's
yeah,
it's
yeah,
very
yeah.
unlikely to.
And then basically after that is just like how does like giving the LLM a good interface for all the human tools that I use to
Yeah,
debug.
yeah.
Like IDA, like record R2. 'Cause
Yeah.
Some of the LLMs are the best at using R2.
Well, it's a command line text interface,
Yeah.
so like that makes sense. They don't have to write API; they can just do.
Then there's also the whole GDB thing. Like, we step through GDB, but like that state is really hard for LLMs to reason about.
Yeah.
So things like that. And then
Yeah, I would expect them to writing like libdebug or writing like scripts would probably be a better use or better.
yeah, but
Your mic is good, but his mic
I'm just gonna.
Okay, we'll just switch this mic and we'll pass it around. We also have Thomas Windmill from Nautilus Institute, who was also very intrigued about this here as well. So we can all chat.
Absolutely. I'm super curious. So for your using like your function calls, were you using like basically raw API function calls? Were you using something like MCP, something else? Like what sort of
No,
tech went into
I
that?
kind of like coded everything from scratch, basically. Just the simplest possible solution.
And then just gave it API access essentially to the things you
exactly.
loaded up and prepared for. Yeah.
So
I think you
give
just
it
lost
the
the bet.
files.
I did just lose a bet.
What did you think it was gonna be?
Yeah.
I thought you were gonna like take Ghidra MCP or IDA MCP or
No.
Finja MCP and like some of the shell MCPs and some other stuff.
No, I think what I've noticed is like it's just easier if I code it for myself and just don't give LLMs too much. Just give just enough that they need to like.
I have fun like reducing the context,
exactly.
reducing errors and logging an output for the tools that they're using even too, and only giving them things that are most relevant is kind of important to it. So, were you expecting them to like do this level of
So
performance?
when I was building, so I built this starting Wednesday night.
Amazing.
Oh wait, no, when does the CTF start?
Yeah,
CTF
Friday
started Friday morning.
Friday morning. Yeah.
Yeah.
So I started like Tuesday night, Wednesday morning, and basically like initially already I saw it was like one-shotting like previous year's challenges.
Yeah.
But I was still worried like maybe it was training data contamination because it had seen the solution. So it was still kind of unknown for me like whether like it could solve it or not. But then obviously like, and then the first two challenges I had issues with like API keys and they just didn't work.
I was going to ask you. We noticed that like those were your solves that the machine didn't do it. It was only like the third one in, I think, where you finally
exactly.
with
So
you
the
solved
first
it.
one, impossible. The LLM's never doing that
Okay.
because it was a lot of like the control flow was broken up in IDA, so I had to go manually like basically fix all of it. And after it was fixed, it was like I guess I could just all the time was spent fixing the control flow in IDA, so that was not happening.
And I don't think you like. I had a challenge called Loki that specifically broke all the tools with a bunch of obfuscations, and I think I also would have suspected had trouble with that if it was in that round.
Yeah, because I just give it the decompiled code.
Yeah.
But then the second one, I had an issue with my API key and it didn't work, but I went home and ran it and it solved it in 2 minutes.
Yeah. So speed hacking is dead.
Maybe. That's wild to think about. Like, what new challenge? Like, what does CTF evolve into in the face of like these sorts of systems? So, I don't know the details of the most recently solved challenge, and I don't know if it was solved by the system. But when you were evaluating previous years' live CTF challenges, like I know the two you solved yesterday were reversing centric.
No, one was rev, one was
The PNG was technically home because it was shellcode in the like.
But like there was
no exploit necessarily as much as like polyglot shellcode essentially. So it was.
But the model didn't need like a working model of where things were in memory and such, right? There was a pointer that was apparent.
Yeah, I mean.
No, actually, my solution it did because basically the way the model, not my solution, the model solution, what it did was it changed the width to be a call immediate opcode. And then
that is different.
Then it put and then it put at the end of the PNG chunk, it put the shellcode in.
Okay, yeah, the ones that we did as reference solutions were not that,
Yeah,
right?
yeah,
They actually
I was
just
really surprised.
were able to like knock it out essentially by making them. That's also why we allocate that big buffer, make them writable, and then just kind of do a short jump into the payload afterwards.
And obviously, this means you cannot use any single width because then it won't like match up with the end of the IDAT chunk. Because basically, the trick is that the PNG parser ignores everything after IEND, so you can put shellcode after that. And then you just set the width, which is the first thing after the header, to be a call immediate opcode.
That is cleaner. It's simpler than the one that we do.
And
Ours
I
was a
mean,
fully
I
constrained
think
one.
that requires some kind of reasoning about what stuff is in memory, but I guess, I don't know.
Yeah, well, even, I guess this, I'm trying to think, even this solution here, right? Like this solution was one where it had to reason about register state, maybe not so much. I mean, it had to leak up a base pointer. It had to take the base pointer that was leaked. It had to use that. So there was some understanding of like relative offsets at a minimum.
There was one challenge from last year, which, or maybe 2 years back, like IOCTL me maybe. That
one of the classic maybe series from
that one was the one I iterated on until like it got a very clean, like it would solve it very often. And I thought that one was like pretty cool because I guess it instantly knew that like what IOCTLs to use. So like on the TTY you use the like window size and get window size, set window size, which like I guess that's what takes the humans the longest time. It instantly just knew that okay, this is the IOCTL to use. And then after that it's like, okay, now I just need to. I think the challenge was just writing like an op chain or something using that on the stack.
So your system is able to do or to like make op chains?
Yes.
Is that mostly through inference or mostly through like, do you have something like Anger Rob or something?
No, it's just I just give it all the ROP gadgets and it just makes it on its own.
Okay, so there's a tool call to retrieve the ROP gadgets. And
Yes.
It goes in both
Yes,
chains.
exactly.
Okay, cool. That makes sense.
Yeah, it doesn't like just get the ROP gadgets. So it obviously.
I don't know.
But honestly,
I wouldn't be too
after
relieved.
yesterday's
It's still coming
solve,
for our jobs.
after yesterday's solve, I think it can find ROP gadgets on its own. Like the VM solve.
Yeah.
Like I was telling him like my I don't know if you heard like it like there was like this exception VM implemented exception handlers, so it figured out the opcodes, then it wrote a disassembler, got the assembly, extracted the bytecode, got the disassembly, then wrote a Z3 script to like get the flag, and then got the flag and then submitted it.
Yeah, I was
It's like
on camera.
six
I am
steps.
on record as saying I don't think the bot's going to get this about 1 minute before the bot got it. Like, that was incredibly impressive that it put those steps together. And you said like this was like 2 days worth of work, a day and a half worth of like.
Maybe like a year of experience as well. But
That's true. It's yeah.
Like the fact that it wrote a Z3 script that was useful. Like I know a lot of people here who would struggle to very
Yes.
quickly produce a Z3.
Yeah.
Like that's.
And the craziest thing is, it would basically just, like, it wouldn't always one-shot it. Like, sometimes the disassembly, like, in one of the traces, the disassembly was wrong, and it iterated over the disassembler, like, 4 times until it fixed it.
Yeah, no, I mean that makes sense too. You see him like as long as you have that feedback loop, that's like the most important thing for being able to get the results out. That was awesome. Again, well done. Congrats for both being the fastest human and fastest bot together. We'll see what this changes to the ecosystem and the environment. I don't know what it's going to do, but any final thoughts?
I don't know what happened to DEFCON CTF when the context lengths become 10 million. Like right now, the DEFCON CTF is good because you can just throw the static binaries, but we'll see next year.
Until like the LLMs just learn out all the static linked things.
And then ignore them. And then, it's kind of terrifying.
I mean, honestly, even for reverse engineering this year, like, Claude was like so incredibly helpful. Like, you could just dump, like, for example, for the NILU challenge, you could just dump the entire like exec command and it would get all the structs, get all the STL stuff, get the move semantics, everything. Like, I didn't trust it, and I like did all of it manually, and then I look at it and it's like, holy fuck, this is correct.
I've been reverse engineering and exploiting for over 20 years now, and it wasn't true a year ago, but probably about 6 months ago, 95% of the time, O3 Pro class models are better than me at reverse engineering and faster.
Yeah, certainly for time. Yeah.
They still occasionally will make a mistake or two that I can pretty quickly pick out, but they are remarkably good, I think.
And also, we humans have a failure rate too. Like, we'll get stuff wrong. And I don't think their rate is necessarily even any different than ours already at this point.
Absolutely, but like I think the skill floor has definitely been raised. I'm excited to see what it does to the skill ceiling as well. But like everybody now has an army of people who are incredibly good reverse engineers if they learn to work with these systems.
Yeah.
Army of solvers.
Yeah, it's it helps an army of solvers.
I think the biggest thing that like worked for me was that the fact that I could just spin up like 30 in parallel or whatever.
Yeah,
Which might be a little bit too OP.
That might be a little overpowered. I do, and that's the thing is, even if it's not, even if we restrict it to, for example, like on-device models, next year we say, yeah, you have to fit it in a laptop on your machine, and nothing can run remotely. Even if we do that, how long is it before even those models are at the capacity of the current ones? Based on the history, it still won't be but a couple years, right?
Or maybe I just bring a H100
Or
here.
drop one of those in the desk.
Then we've got to like restrict what they bring.
Yeah.
You have to provide the
Power
hardware,
we'll limit
money
your power.
wins.
We'll just limit your power, this wattage for a player. I don't know what that looks like. All right. Well, thank you very much. Congratulations. We'll let you back to the regular event. And
Thank you for organizing this.
yeah, you're very welcome. And we're gonna go ahead and I think sign off here. We'll walk back to make sure that we can close down the stream here in a bit. We'll hop on with Carl. We'll do one final.
Wait, you-
Sorry if we were muted there. I looked at my mic and I wasn't sure if it was muted or not.
No.
so-
You're like we heard you on.
You heard the whole thing.
Yeah,
Okay,
yeah. I
great.
listened to the interview. So that's all good.
welcome.
Yes. So we're back here in the studio.
Back in, which is like 20 feet away.
So yeah, so we just had the interview with the winner from Blue Water with Jordan and Dustin from Knowledge Institute, who are like the
Thomas Windmill.
Windmill.
Yeah. I've done the same. It's fine.
Who are the kind of the organizers of kind of the main portion of the
Yeah.
CTF.
And so as we were saying earlier, like there is going to be a pretty potential big point swing here at the end. So depending on what happens today, MMM has a big lead that they were showing on the scoreboard, but they were also out in position 7 and 8 in our tournament. So that results in a decent like 73,000 point swing between the first place in Blue Water, who is second in the overall event, but first in LiveCTF. So I don't know if it'll be enough to get them over the first place. I think it looks like MMM is certainly still in the lead, but we'll see. And there's still a little bit of game left to play.
Yeah. And with that, I think we're kind of getting to the end of the live CTF, and also not only like the end of this live CTF, because so we have now done this for 4 years together with Knowledge Institute, which means that there will be a new group organizing the DEF CON CTF next year. So we may or may not be back next year. We'll see what happens, but I would say, maybe we're just kind of like saying goodbye to live CTF in this iteration for now, and then we'll see where and when we come back. We have an invitation for another thing, but let's we'll keep that.
See about,
you
see
will
about that later.
Hear about it when and if that happens. I would just like to also thank everyone who we have collaborated with. Of course, you've seen Mark and Josh here on commentary. We've had Glenn also in our team who have built many of the challenges.
Glenn had built most of the challenges, I think, by numbers, right? Or was it you or him? You were pretty close.
If you count sudden death challenges, he is definitely in the lead. I think if you don't count them, it's kind of even between the two of us throughout the year. So the 5 of us have been kind of like the core group throughout these 4 years, and we've had a couple of other people helping out.
Rusty's done a lot, particularly this year, and a couple in the past years.
For example, Rusty made a couple of challenges. For example, the not this one, but the previous challenge that we saw. We've had people with us here on the floor. Kyle this year, for example, been big help. And, a handful of other people previous years who helped us make this a really nice event.
Yeah, we appreciate it. It takes a lot of work, and we're going to close down the stream here just in a second. We'll finish packing up. If you're at DEF CON, feel free to come on by and say hello. We'd love to see you, especially now that we're going to be off camera.
We have stickers.
We have stickers, so come by and grab some of those.
Also, as usual, all the challenges are going to be on our GitHub. I would say,
whenever we recover.
It's maybe next week. Hopefully like next weekend or something. They will be up there. We'll see when I recover from my jet lag back in London. But everything will be online, so you can like work through the challenges yourself and try them. Maybe see if you can write
build your own bot. Yeah, exactly.
Cool. And
sounds good to me.
Yeah.
Thanks everybody. We appreciate it.
Thank you.
It's been a fun 4 years.
Goodbye.
Take care.